Welcome to Aptronic Software Education channel. Today, in this episode, we are going to learn about some basic concept of light. Without wasting any more time, let's begin. Light, a word all of us are familiar with from our childhood, something which helps us to see things around us. Or say, light is an indispensable tool to explore the colorful beauty of nature, such as blue color of sky, white color of clouds, red color of sunrise and sunset, sparkling pearls, diamonds, and so on. Scientifically, light is a form of energy which produces in us the sensation of sight. We know that at night, when we switch on the bulb, everything in the room becomes visible. But nothing can be seen when the bulb is off. During the day, we are able to see the world around us due to the light from the sun. But exactly what does makes things visible? When a light falls on an object, it reflects back in the same medium. This reflected light, when received by our eyes, enables us to see things. Now, due to this small wavelength of light, it produces negligible diffraction. So by this statement, we can conclude that light travels along a straight line. When light traveling in medium A strikes the boundary of any other medium B, it reflects and thrown back into the original medium A. So, the bouncing back of light in the same medium after striking the surface of any object is called reflection of light. Remember, in reflection, path of light rays changes without any change in medium. Now, let us see types of reflection. There are two types of reflection: regular reflection and diffuse or irregular reflection. When the reflecting surface is smooth and well polished, the parallel rays falling on it are reflected parallel to one another. That is, reflected light goes in one particular direction. This is called regular reflection. The best type of example of this type of reflection is mirror. As it is highly polished, it reflects most of the light falling on it and we are clearly able to see our image. Now, when the reflecting surface is rough, the parallel rays falling on it are reflected in different direction and it does not reflect an image. This type of reflection is called diffuse reflection or irregular reflection or even scattering of light. There are two laws of reflection. The first law states that the incident ray, the reflected ray and the normal all lie in the same plane. As we can see in this image, the light falling on plane mirror along AO is reflected along OB. Therefore, AO is incident ray, OB is reflected ray and ON is normal to the mirror at O. So according to the first law, AO, OB and ON all lie in the same plane of paper. According to second law, angle of reflection R is always equal to the angle of incidence I. Now, angle of incidence is the angle which the incident ray makes with the normal to the mirror, and angle of reflection is the angle which the reflected ray makes to the normal with the mirror. So, in this image, angle AON is the angle of incidence and angle NOB is the angle of reflection. So, according to this law, angle I is equal to angle R. So, if angle of incidence is 30 degree, angle of R will also be 30 degree, and angle of incidence is 60 degree, angle of reflection will also be 60 degree, and so on. Note that these laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. A spherical mirror is that mirror whose reflecting surface is a part of hollow sphere of glass. The reflecting surface of a spherical mirror is curved inward or outward. So, the one side of a spherical mirror is reflecting and well polished and the other side of the mirror is opaque. There are two types of spherical mirror. First, concave mirror. Concave mirror is that spherical mirror in which the reflecting surface is towards the center of the sphere. That is, reflection of light occurs at concave mirror or the bent edge surface, and the other surface B of the concave spherical mirror is opaque or non-reflecting. Second type of spherical mirror is convex mirror. Convex mirror is that spherical mirror in which reflecting surface is away from the center of the surface. That is, reflection of light occurs at convex surface, that is, bulging out surface A, and the other surface B is non-reflecting or opaque. Now, let us see how we can distinguish between plane mirror, concave mirror and a convex mirror. First, a plane mirror produces virtual, erect image of same size of our face, that is, we look our normal self. Concave mirror produces virtual, erect and magnified image of our face, that is, our face looks much bigger when held within focus of the mirror. A convex mirror produces virtual, erect but diminished image of our face. That is, our face looks much smaller. Let us see some examples of first convex mirror. A convex mirror is used as a reflector in street lamps, as it diverges the light from the lamp over a large area. Second, a convex mirror is used by drivers of automobiles as a rear view mirror because a convex mirror produces an erect image of the object. Second, size of the image formed by the convex mirror is much smaller than the object. And third, convex mirror have a wider field view as they are curved outwards. Therefore, convex mirror enables the driver to see much larger area than would be possible with a plane mirror. Some examples of concave mirror are: first, concave mirror is used as reflector in torches, searchlights, headlights of motor vehicles, etc. to get a powerful parallel beam of light. Second, a concave mirror is used as a doctor's head mirror to focus light on our body parts like eyes, ears, nose, teeth, throat, etc. A concave mirror is also used as a shaving mirror or a makeup mirror as it can form erect and magnified image of our face. Large concave mirrors are used to concentrate sunlight to produce heat in solar cookers, solar furnaces, etc. Let us recall some of our day-to-day observations, like a coin in glass tumbler filled with water appears to be raised when seen from above of the water, or a lemon kept in water in a glass when viewed from the sides appear to be bigger than its actual size, or a pencil partially immersed in water appears to be bent at the interface of air and water. Let us see why this is happening. For example, aberrant bending of pencil at the interface of air and water shows that light reaching us from the portion of the pencil inside the water is in different direction than the light reaching us from the portion of the pencil above water. That is, when light enters from air medium to water medium changes its direction. So, the phenomena of change of path of light from going from one medium to another is called refraction of light. Refraction occurs right at the boundary of two media. Here, xy is a plane surface separating medium 2 from medium 1. A ray of light travelling in medium 1 along AO strikes the boundary xy of two media at O. In medium 2, the ray light travels along OB, which is not in the line with AO. The ray travelling along AO bends towards the normal NO N' and goes along OB. This change in path or bending of light occurs at O, that is, The light is refracted at O when it goes from medium 1 to medium 2. Here, AO is called incident ray, OB is called refracted ray, O is the point of incident at which the refraction occurs. N, O, and dash is normal to the plane surface XY separating the two media. Now, the angle which the incident ray AO makes with the normal NO and dash is called angle of incidence and is represented by I. So, here angle AON is angle of incidence, and the angle which refracted ray OB makes with the normal NO and dash is called angle of refraction and is represented by R. So here angle BO and dash is angle R. So remember, in case of reflection, the angle of reflection is always equal to the angle of incidence. But in the case of refraction, the angle of refraction R is never equal to the angle of incidence I. Now, when light travels from rarer to denser medium, it bends towards the normal. And when light travels from denser to rarer medium, it bends away from normal. There are two laws of refraction of light. First states that the incident ray, the refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same plane. And the second is the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. That is, sine I upon sine R is constant. This is also known as the Snell's law of refraction. Lastly, there is a formula known as mirror formula. By using this formula, we can easily find the image distance or object distance or focal length of any type of mirror. Mirror formula is a relation between object distance U, image distance V, and focal length F of a spherical mirror. And it can be written as 1 upon object distance plus 1 upon image distance is equal to 1 upon focal length. Now, if R is the radius of curvature of a spherical mirror, then focal is radius of curvature upon 2. For updation on educational topics, continue to watch Aptronic Software Education channel. Thank you.